Hi, Year 10s. I'm just going to record a quick video for you on turning point and how to find that. So I've got a quadratic here. It is f of x equal to x, 2x squared minus 3x plus 4, and it is with no scale. It is just sitting there. So we're going to try and find the turning point. What we're going to do is I'll do some working out and I'll show you how to do this. So 2x squared minus 3x plus 4 is our turning point. So I'm just going to write that down now. We'll go f of x. F of x is equal to 2x squared minus 3. Oops, that's not a very good 3. What happened there? Come on, come on. There we go. I'll do that whole little section again. This is yet more new software for me. 3x. Was it plus 4? Let's kind of have a quick look at that. Yes, it was. Okay, so the way we do this is we want x of the vertex. Trying to correct my handwriting for me, occurs at negative b over 2a. Now what we need to remember is where these values are coming from. A normal quadratic, not a normal quadratic, lots of things are normal with quadratic. The general form of quadratics, it's written like this: y is equal to ax squared plus bx plus c, and a can't be 0. And this number here in front of the x term, and this number here in front of the x squared term, in front of the x term, are really relevant to us. So we've got here a, sorry, I should do it on the other side. Let's go over here. A, the term in front of the x squared term is 2. B, the term in front of the x term is negative 3. So this is what we're going to do. We're going to negative b, which is negative 3, over 2 times a, which is 2. 2 times 2. Right, so this is the negative of a negative on top is 3/4. 3/4. Negative times negative is 3. 2 times 2 on the bottom is 4. So our x value, x, is equal to, oh, I don't like it when my x's overlap like that. They're not meant to. There we go. X is equal to 3/4. Now, what we need to figure out is what y equals when x equals 3/4. So the reason we need to do this is because we are finding the vertex. The vertex is a point, x and a y. I'm just going to write it like this as well. Whoops. It's some number here. We now know that's 3/4. But also, we need to figure out the y. The way that we figure out the y is figure out what this number is when we put it back into the function. So we're going to put it into the function. We used our little x of the vertex equal to negative b over 2a. We used our values from our quadratic. We put those in. We've got x equal to 3/4. Now I need to figure out what this equals. So I'm going to go 2 multiplied by, replace all of the x's with 3/4 squared, minus 3 times 3/4 plus 4. Now I hope what you can see is that this x and this x have been changed to, let me pick another color here, there's a lot of orange going on. This 3/4 and this 3/4 and all the other stuff is the same. There's a 2 in front, there's a squared here, there's a minus here, 3 plus 4 in the end, the only thing that's changed. So we're just going to get the number that goes with this. So here we go. We're going to go 2 now. 3/4 squared is 3/4 times 3/4, which is equal to 9 over 16. I knew that, but I wanted to show you. Now I'm going to 2 times that. So that's 18 over 16. 2 times 9 over 16 is 18 over 16. Minus, I want 3 times 3/4. Well, 3 times 3/4 is 3 times 3, 9 quarters plus 4. And a little bit of jiggery-pokery with the denominators here would give us 18 out of 16 minus, I can multiply top and bottom by 4, and I will get something out of 16. 9 times 4 must be 36. Plus, I can multiply top and the, remember there's a denominator of 1 if I need it. I can do 64 over 16, that's true. It's equal to, right, 18 minus 36 is negative 18 plus, how did I get that right? 18 minus 36 is, yes, negative 18. Negative 18 plus, is that 46? Is that 46 over 16? I've made errors before. Yes, it is 46 over 16. Over 16, which is the same as, they're both positive. So they're both even. I can halve them both, 23 over 8. And I don't think I can do any better than that. Now, I'm not loving this number, but I hope it's correct. Now, I hope what this is telling us is, let's just make this a bit fatter. Let's go here. A turning point should be 3/4. That was the x value. Now, y value, which comes from f of x, should be 23 over 8. That's what we think it is. So let's go back into Desmos and see if that works. 3/4, 23 over 8. Let's put it in. All right, 3/4. Oops. 23 over 8. And we'll go look at that. There it is. 3/4, 0.75, 2.87 is 23 over 8. But there we go. That's how we find the turning point of any quadratic.